Okay, guys, this lesson is intended to go along with the PowerPoint video that I posted on elements with multiple ionic charges. So from that video, you should have taken away that there are a few transition metals, those metals in the middle block of your periodic table, that actually are capable of forming more than one ionic charge. And this is important when you're naming and writing the formulas for compounds that are formed with one of these elements, because you have to decide which ionic charge was actually used. So for the duration of this lesson and anything moving forward, please keep referring to the reference chart that I've uploaded to the Google Classroom, where you have the various elements that actually do have multiple ionic charges and what those charges are. So our first example is going to be CuBr2. So given this formula, what's the name? Okay, so we are going to name this formula. So there's a series of steps that I now want you to follow when solving problems in nomenclature. So step one is going to be, let's change the color of this pencil. Step one, is it ionic? So this may seem silly because you've only learned about ionic bonds and compounds so far, but moving forward, we're going to learn about different types of bonds. So the first thing that you're going to ask yourself, well, is it an ionic compound? Well, copper is a metal and bromine is a non-metal, so yes, it is. Once you've decided it's ionic, you're then going to have to ask yourself this second question, and you are always going to have to ask yourself this second question. Does it include a metal with a multiple charge? And how are you going to know that? Well, you're going to look at the metal in your formula, so the first element, and you're going to compare it to the reference list that you have on elements with multiple charges, okay? So does it include a metal with multiple charges? In this case, it does. So if you answer yes, you have to decide which charge is actually being used. So copper has two possible charges. So copper can have a charge of 2+, or it can have a charge of 1+. And before we go and write the name of this formula, we have to decide, is it the 2+ ionic charge or the 1+ ionic charge that was used? And it's really easy to figure it out. So step 3, I'm going to write step 3 over here to the side because I've run out of room. Step 3 is you're going to do the crisscross method, but you're going to do it backwards. And what do I mean by that? Well, I will show you. So let's just go over these steps again. So every time from here on out that you are naming a formula, the first thing you're going to ask yourself, is it an ionic compound? Ionic compounds are formed between metals and nonmetals. If it is, you're going to move on to the next question. Is it an ionic compound that includes a metal with multiple charges? So refer back to your reference sheet and check the metal. Copper is on that list. So now you're going to go to step 3. You're going to figure out which charge it is by using the crisscross method backwards. And so let's do that. So we have CuBr2. So I'm going to write my two symbols beside each other, and I'm going to crisscross the charges backwards to see what happens. So that 2 originally came from the copper, and this invisible one here would have come from the bromine. So that's step 1. So you're going to write out the symbols and you're going to do the crisscross method backwards. Then you're going to check your nonmetal. You're going to check that the charge on the nonmetal is actually correct to ensure that your actual formula wasn't reduced, because maybe it was reduced and we don't know. So we're going to go to our periodic table and we're going to figure out what the ionic charge of bromine is. The ionic charge of bromine is actually 1-, so this is correct. So I know that this formula has not been reduced, which means that the charge on copper is actually 2. So this is what I'm going to use when I name my compound. So how do you name it? Well, the nonmetal stays the same as it normally does when naming ionic compounds, meaning the ending changes to IDE. Your metal stays the same, meaning you don't change the ending. It's going to be whatever it is. In this case, it's copper. But now, after the metal, you are going to have to include which charge was actually used. And in this case, copper used its 2 plus charge. So I'm going to represent that by using the Roman numeral 2, just like the video showed you. Now, you are only using Roman numerals when you're using elements with multiple ionic charges. If your element does not have more than 1 charge, you are not including a Roman numeral. Please do not make that mistake. The Roman numeral is only used for those certain metals, transition metals specifically, that have actually more than 1 ionic charge. Okay, so it's not used for every metal, so don't do that. And the Roman numeral comes right after the metal, right before the non-metal. Okay, so the name of this compound is actually copper 2 bromide. If you don't include the Roman numeral and the ending IDE, you are not getting the question correct. Okay, let's try another one. Let's write the name of PbO2. So again, let's write out our steps. Is it ionic? And again, you can pause this video at any time to write yourself a series of notes, have a flow chart of questions you're going to ask yourself to make everything a lot easier. So the first thing, is it ionic? The second thing, does it have a multi-charged metal? Okay, so if you answer yes to ionic, perfect. Move on to the next question. Does it have a multi-charged, that's a D, a multi-charged metal? In this case, yes, it does. And we are going to indicate what the 2 charges possibly could be. So lead, again, is on your reference list. Lead can either be 2 plus or it can be 4 plus. Okay, and then we're going to decide, step 3, we're going to decide which charge it is by doing the backwards crisscross method. Okay, so let's do that. So the first thing I'm going to do, I'm going to erase this. I'm going to choose a different color. So my formula is PbO2. So I'm going to write Pb and I'm going to write O. Then I'm going to work backwards. That 2 came from the Pb. This invisible 1 came from the oxygen. Now I'm going to check my nonmetal. I'm going to check my oxygen to see if this ionic charge is correct. If it's not, it means that the formula has been reduced. Remember, we always reduce our formulas, just like in math. So let's check oxygen. Well, oxygen actually has a charge of 2. So this actually should be a 2, which means this formula was reduced. So how did that go from the 1 to the 2? Well, you multiplied by 2. So what are you going to have to do with this 2? This 2 is actually going to have to be multiplied by 2 to give you a 4. So really what this formula would have looked like before it was reduced is this 2 comes here and this 4 comes here. It would be Pb2O4. But when you reduce it, it becomes PbO2, right? Because they both get reduced by 2. So what was the actual charge on lead originally before it was reduced? It was 4. So when I go to name this, it's going to be lead 4 oxide. Okay? Let's try another one. We are going to do MnO2. So we're going to write the formula for MnO2. So step 1, is it ionic? Yes, it is. Manganese is a metal. Oxygen is a nonmetal. Does it include, step 2, does it include an element with multiple charges? Yes, it does. Manganese can have 2 charges. Manganese, or actually 3 charges. It can be 2 plus, it can be 3 plus, or it could be 4 plus. So we need to decide which charge was actually used. So how are we going to do that? We're going to work backwards. So let me change the color of this. So you have Mn and you have O. If I do my crisscross method backwards, the way it is, There's a 2 on the manganese, and there's a 1 on the oxygen. Now, check your non-metal to see if that charge is correct, or if it's not, it means that the formula has been reduced. So we just realized that oxygen has an actual ionic charge of 2. So I'm going to cross this out and make it a 2, right? That means I multiplied by 2. Which means, what do you have to do with your manganese? You also have to multiply it by 2. So really, the charge of manganese was 4 and the charge of oxygen was 2. And when you crisscross, you are going to get Mn2O4, which can be reduced to MnO2, which is what we started with. So what was the actual original charge on manganese? Well, it was the 4. It was 4 before it was reduced. So what is the name of this compound? It's going to be manganese 4 oxide. Okay? We're going to do one more example where we actually write the name of a compound from a formula, and then I'll give you some time to practice, okay? So what if you were given the name iron 3 nitride and you were asked to write the formula? Well, this is really easy. The hard part has been done for you. The Roman numeral tells you which charge has been used. So you're going to do your crisscross method. Iron is telling you the charge is 3. Nitride is nitrogen. When you refer back to your periodic table, nitrogen has an atomic number of, let's see, 3. So you are going to crisscross, and it's going to become Fe3N3, and now you're going to reduce. Both of these can be reduced by 3, so you're going to be left with FeN. Okay? Shall we try one more? What about if we were given iron 2 bromide? Again, write out your symbols. Oh, it's bromine, not oxygen. So iron, it's telling us that it was the 2+ charge that was used. Bromine has a charge of 1-. You are going to crisscross, and you are going to be left with FeBr2. Very simple. Okay, so read over this. Or listen to it rather. Watch the PowerPoint video, and if you have any questions, email me, okay?